into today's topic, which is so numpy operations. Okay, so as of now, we are familiar with the basics of numpy, right? Now it's time to delve a bit deeper into different functions and operations which we can do using numpy functions, and let's see how we can move around with or play around with the vectors and matrices or simple nd arrays in Python. You right? So the first topic is array manipulation. Okay, so you can basically manipulate your arrays. So there are some methods. Of course, these are not exhaustive. Okay, there are a lot of different functions and methods associated built in NumPy library, which we won't be able to cover, right? But of course, you can consult the actual documentation of NumPy, which will have all the functions and methods defined in the library, right? So because NumPy is a very vast library, it has a lot of functionalities. Okay, so we'll of course not be discussing every one of them because we don't need them. But if you need anything in particular, you can just consult that documentation, the original one, and you can get yourself going on. All right. So the first is numpy.transpose. So this creates a transpose of an array. Okay. So what is a transpose? So transpose is defined as an operator which flips a matrix over its diagonal. That is, it switches the row and column indices of the matrix A by producing another matrix, and we denote that by A transpose. So for example, if this is your matrix, so you have 3 rows and 2 columns. If you transpose those, so your rows becomes your column and your columns become your rows. So right, see, so this was your first column, now this is your first row. This was your second column, now this is your second row, right? So you just switching your rows and columns. Okay, and that's it. Okay, so let's see a few example of creating such a transpose. So here I have a 2D array which I'm calling Aravali, and I'm so this is uh, this consists of some random integers between 10 and 45, and the shape is 8 comma 2. That means there are 8 rows and 2 columns. Okay, so if you see this, so the shape is basically 8 comma 2, right? Now we can transpose this array, and I'm storing this in Nilgiri, another 2D array, in which what I'm doing, I'm writing this function np.transpose, and within parenthesis I am providing this array whose transpose I want to find out. Okay, so I can just go ahead and print this particular 2D array in which I've stored the transpose, and and I can print the shape. So you can see the transpose is basically your rows are getting converted into columns, and your columns are getting converted into your rows, and the shape is also reversed, right? So earlier we had 8 rows and 2 columns, now we have 2 rows and 8 columns, right? So this is pretty intuitive, right? So just have to interchange the rows and columns. Let's take an example of a 3D array. So here I have 3 layers, 2 rows in each layer and 4 columns in each row, right? So 3 layers, 2 rows in each layer, and then 4 columns in each row, right? So I'm taking a simple transpose here. So so I'm taking a simple transpose. So as you can see here, so the shape is 3 comma 2 comma 4. Now the shape is getting changed to 4 comma 2 comma 3, right? So see, 17 was here. Now next 21 will go to the next layer, then 24 will go to the next layer, and then 21 will go to the next layer. Okay, so here the number of rows in each layer is preserved, but the columns and the layers, they are interchanged. The lengths of those are interchanged, right? So you can just have a good look at this one, right? So 26 is still here, right? Now we're getting 31 here, right? Now from 23 here, right? So similarly we can get a transpose of a 3D array as well. So this is also pretty intuitive. So you can see the shape was initially 3 comma 2 comma 4. Now the shape is 4 comma 2 comma 3, right? So I'll just run this basic one so that when I need it, So in this way, you can basically create a simple transpose. So transpose is just mostly we'll be dealing with 2D and 2D arrays and sometimes 3D arrays, but mostly 2D arrays, right? Which is also called as a matrix, right? So yeah, taking a transpose means interchanging your rows and columns, which is pretty straightforward. Now there is another way in which we can manipulate our array. So there is a reshape function. This is pretty useful. So when you do when you do modeling, okay, so or whenever you are doing studying deep learning, so these things will become really important. Okay, so numpy has a lot of utility in when it comes to deep learning, though its use is sort of restricted when it just comes to learning your traditional machine learning algorithms. Okay, so most of our work when we are doing machine learning can be done with the help of pandas. Okay, but numpy will be very useful when we are learning deep learning. All right, so just keep that in mind. So this reshape function, so I how do I call that? By np.reshape. Okay, so you remember how I got np, so I just imported numpy as np. Now this gives a new shape to an array without changing its data. So suppose if I have this data, which is a one-dimensional array of 6 elements, right? If I write, there are different ways to create reshape an object, but yeah, so there is you can call the reshape method, okay, on the nd array, or you can also call the uh, np.reshape function, and in this you can provide the array which you want to reshape. So we'll go with this method, but this is for your understanding. Suppose this is a one-dimensional array and you want to reshape into an array which is of size 2 comma 3, right? So 2 into 3 is 6 elements. So this of course the same number of elements we are having in this case, and this will create 2 rows and 3 columns. So you can see you just move row wise. So 1 2 3, so 1 2 3, then 4 5 6. Now suppose you want to reshape this particular 1D array into another array, two-dimensional array in fact, which is of shape 3 comma 2. That means you want to have 3 rows and 2 columns. So here also just 1 2, okay, the first row is now over, then 3 4, the second row is over, then 5 6, the third row is over. Okay, so in this way you can reshape your data. So the thing is, uh, whenever you are reshaping, so the original the total the size of the array should be equal to the size when you are reshaping it. Okay, so that is a basic constraint when you are reshaping it. So for example, I cannot reshape this particular 1D array into another array which is of size 2 comma 2. Okay, so that you have to keep in mind. So let's just go through a few examples and this will become pretty clear. So again, I'm creating a 2D array. Again, I'm having these elements are between 10 and 40, 45. These are random integers, and the shape is 3 comma 8. That means we have 3 rows and 8 columns, right? Now I am calling the np.reshape function, and what are the arguments it will take? So it will take the array which we want to reshape. Okay, so and the new shape. Okay, so the new shape here I am providing as 2 comma 4 comma 3. So if you multiply this, so 2 into 4 is 8, into 3, that is 24, and if you see the original array, it is 3 into 8, that is 24 elements. So we'll be able to reshape this one. So I'll just go ahead and run this one. So yeah, so yeah, can you give me another example in which we can reshape this particular array? So let's say my restriction is I want to have a 3D array. Okay, so what other 3D array with what shape we can create? Can you write in chat? Okay, so just an example, give me a tuple of 3 numbers. Okay, so someone says 2 comma 6 comma 2. So let's go ahead and run this one. Yeah, so this will give me 2 layers in which each layer will have 6 rows, and then each row will have 2 columns. Of course, we can have a lot of other possibilities. For example, Isha is saying 4 comma 2 comma 3, and then Raj is suggesting 3 comma 2 comma 4. Then we can have a lot of other shapes, but the constraint is the size of the new array and the size of the previous array, they have to be same. Okay, that then only, yeah, a reshape makes sense. Okay, so hopefully, yeah, this is clear to you. One important thing is, suppose you know that let's say in a new array which you want to reshape into, you say, let's say it's a 2D array, and you think that, yeah, I should have four columns, but I don't know what should be the number of rows. Okay, so you if you are not sure about, or you don't know, so this -1 stands for means undetermined from user, but numpy will automatically understand that how many rows it wants to create. It will do the calculation, and this will generate the new array. Okay, so let's go ahead and run this one. So this will become clear to you. So see, each row will have 4 columns, right? So I initially had 24 elements total, right? So how many rows it will create? 6 rows, right? That was simple, right? So if you're not sure about, yeah, so if you're not sure about basically what should be number of rows, then you can provide -1 here. Okay, and yeah, this will automatically, so suppose if this is 6, okay, so I want to have 6 columns. Okay, so if I run this one, sorry, yeah, so yeah, so the shape of the new array is 4 comma 6, right? So the simple thing is, see, you can see how we're able to reshape it. So our initial array is this one, 20, 20, 21, 35, 90. So it's just moving in this order only. Okay, so see, in the reshaped array, 20, 21, right? So I can only have maximum 2 columns. Then I move to the second row. Okay, so I will have 35, 19, then 30, 19. So just if you are not sure how the elements are being filled, so just move row wise. Okay, and in that order, basically you will be seeing that the elements are being filled. Okay, so you can see that, yeah, 30, 33, then 12, 31, 13, 20, 29, 40. So in this way. Okay, so in this way the elements are getting filled. Okay, so hopefully this is clear to you. And also you understand the concept of -1. So suppose if I have 3 here, so what do you think the number of rows will it create? 8 rows, right? So it's creating 8 rows. And yeah, so there is a genuine question. So can we make this 4? So can we fix the number of rows, and can we have this the number of columns? In fact, we can have that as well. So, right? So yeah, if you're not sure about how many, so this is pretty useful. So suppose yeah, so if I want to create, let's say, what do you think this will create? Yeah, how many elements are we having? 24. So what will this create if I am writing -1 comma 1, right? So I'm fixing the column size to be 1. Okay, so I'll just go ahead and run this one. So see, it's, yeah, so each element, yeah, so there is yeah, so I'm just restricting this to 1 column. Okay, so I'm having elements in this way, right, in my reshaped array. Okay, so there are 24 rows, in fact, right? So this will be very important. So this particular functionality, so when you are actually passing your model data into model, when you are training a machine learning algorithm, so this will become really handy in case. Okay, so yeah, so suppose you'll have to do such transformations in which you have to apply this reshape function. Okay, and the shape you can provide -1 comma 1. Okay, and in this way you can create the reshaped array in this way. So we'll see when we actually do machine learning, that will be using at least once this reshape functionality from numpy. Okay, so this is also pretty straightforward. Okay, so right, can we yeah, have another -1? What do you think? Can we have this one, another -1? So suppose this is 4. So I'm not sure about my number of layers. I'm not sure about the number of columns, but I'm sure about the number of rows. Do you think this will give me any output? What do you think? So this will give an error. Why? Because you can only specify one unknown dimension. Okay. So in this way, yeah. So you can only specify one unknown dimension, right? And which numpy will automatically calculate that this should have these many dimension values, right? So when I provided the number of columns should be 4, so you automatically calculated the number of uh, rows should be 6, because we have to preserve the size of the original array and the reshaped array. All right. So yeah, so we have seen this example, right? So one second. So Yagni is having one question. So suppose if I am having 2 minus 1 comma 6, right? So sorry. Yeah. So so yeah, I'll just run this on. So suppose yeah, if I fix the layers to right this one, so it automatically calculates this one. Okay, so you should have only one unknown dimension. Okay, so I hope that is clear to you. Okay, now let's go to the resize function. So the thing is, you can either have a resize method on an nd array object, because method is a functionality associated with an object, right? So in case we are dealing with nd arrays, that is n dimensional arrays, so they will have methods associated with them. But we can also do an alternative thing in which we are using a function. Okay, so we're using, for example, numpy.resize function there. Okay, but of course resize is also a method available with an nd array object. So here whatever examples I'm showing you, I'm using the function. Okay, so there are bit of differences between these methods and the functions. More or less they are doing the same operations, but there are certain differences which we should not bother about for now. Our main objective as of now is to understand what these methods or functions manipulate our array, right? So this resize changes this shape and size of array in place. So not only it changes this shape, but it can also change this size. Size means the number of elements. Okay, so let's see an example. So here in this, I am having an array in which I have 2 layers, 4 rows in each layer, and 6 column in each rows. Okay, so yeah, I'll just run this one. So 2 layers, of course. So the shape of this array is 2 comma 4 comma 6. Now I can resize this. So suppose I don't have to keep this fixed. Okay, so 2 comma 5 comma 6. Okay, the initial is 2 comma 4 comma 6. If we're reshaping it, then we had to preserve the size in the new array, right? But when we are resizing it, we don't have to worry about it. So I can have 5 here. So what is the size of this particular array? This is 4 into 2, that is 8 into 6, 48. But in this case, I will have 60, the size is 60, that means 60 elements. So how this will generate the next extra elements? So let's go ahead and see that one. Okay, so I'll just run this one. Okay, so you can see that the shape of this array is 2 comma 5 comma 6. Okay, so what's happening here? Okay, so see these two last rows, they are just coming from the top of the array. So essentially when it has run out of all the 48 elements from your original array, Yeah, you remember there were 48 elements in this original array. So what about the next 12 one, right? So it just starts filling from the very beginning only. Okay, it starts filling from the very beginning. Okay, I'll show you another example in which I'll use the method, not the uh, function, np.resize. So see, this is a 3D array, so it gives me a lot of functions here, methods in fact on for this object. So I'll just click on this resize, and suppose I want to resize this to a new shape. Okay, so what this will give me, so I'll just print the random 3D cohort now. Okay, so see, when it has run out of 48 elements in the original array, it's just filling all the next 12 elements with 0. But when we are using the np.resize, the function, when we are using this, so it's filling with the values starting from the array itself. Okay, so it's filling the values from the array itself. But when we are using the resize method on this nd array object, okay, and this will just take one argument here. So the shape of the shape in which we want to resize it. Okay, so once it has run out of the number of elements from your original array, so it will just append the zeros afterwards. Okay, so suppose let's say not two four two, let's say if we want to have fewer elements, so of course let's say 3, so this will have 36 elements. And let's go ahead and get this one. Yeah, so the shape is 2 comma 3 comma 6, and it is just only filling till 13. So it's not filling these 34 28 33, these two last rows, right? So I hope that makes sense. So just important thing to keep in mind when we are using this function, that is np.resize. Okay, so that will take two argument, the array to be resized and the shape of the new array. Okay, but when we are calling this resize method, okay, so so this changes our original array as well, right? So when I ran this particular one, this does not give me any output, but when I went ahead and tried to print this one, so I saw that this array has been already mutated or modified. Okay, so the resize method changes your array. All right, so it's essentially resize is changing the shape and the size of the array. Size is, it can also include any extra elements depending on the new shape which we are providing. So hopefully that is clear to you. Okay, now the next is np.flatten. So it's by the name you can kind of comprehend that it flattens your arrays. So essentially, if it's a 2D array or a 3D array, it will return a flattened 1D array. So suppose I have a 3D array in this case, so which has 2 layers, 4 rows in each layer and 6 columns in each rows. Okay, so if I just call the flatten method, okay, on this object, so this will return a 1D array which is flattened, right? 1D array, that means, and see, you can see all the elements are in order, in fact, right? 21 15 19 14 23 24, see 16 here, so 16, right? Then you have 35 38 21, like that. Okay, so in this way you can, so either we can call the flatten method, or we can in fact call the np.flatten function as well on the object. Okay, so so this is the basic idea about flattening. So we'll also be using this later on. So suppose we want to create a one-dimensional array from a two-dimensional array or a three-dimensional array. So we can just call the flatten method or np.flatten function, and this will just flatten our array. Okay, so I can also, right. So there is, sorry. So you can call the flatten method on top of your 3D means the array object. Okay, and there is also another thing which you want. So suppose you want to flatten it row wise. Okay, so in this case, uh, yeah, so I'll just run this one because this is a random array and gets updated. So see, it's sort of, yeah, giving the same output, but yeah, if we want to, yeah, we can also flatten this array in column major as well, but that is not important as of now. So there are different values which this order can take. Okay, so if I, yeah, change this to F, okay, so this will flatten the array in a slightly different way, right? So how this is flattening? So 21, then 35, then 27, then 41, then 28, then 30, right? Then 29, then 24. So it's sort of flattening in column wise, right? But by default, the flattening happens row wise. So you can just move like this. You can move horizontally like this, and you can have this sequence of elements in your one-dimensional array. Okay, so the main purpose of this flatten method on your for your ND array object is to return return any 3D or convert any 3D or 2D array into one-dimensional array. All right, now we can do a lot more operations or manipulations in uh, to our numpy arrays. Okay, so there is numpy.insert, there's numpy.append, there's numpy.delete, then there is numpy.unique. So we'll go one by one. So there is numpy.insert. So what arguments does this take? So the first is your input array, the array in which we want to insert something, then the object, so the index before which insertion is to be made. So we have to specify the index before which insertion is to be made, then the values, the array of values to be inserted, okay, and then access. So the access along insert in given array. So if this access is not provided, your array will be flattened. So it's a very important concept of access. Okay, so access is defined for arrays greater than one dimension. Okay, you keep this in mind. It's not defined for 1D arrays. It's only defined for arrays with more than one dimensions. Okay, so access 0 means you have to move along the rows. Okay, in this case you have to move vertically downwards, and the axis 1 means you have to move horizontally rightwards. That means you have to move through columns. Okay, so we'll see in an example how we can insert a particular values in a before a particular index and along a particular axis. Okay, so here I am creating a 3D array in which I have two layers, 3 rows in each of those layers, and 4 columns in each of the rows. Okay, so I'll just create this one. Okay, now I want to insert along axis is equal to 0. That means I want to add another layer, right? When you're talking about inserting along axis is equal to 0, that means your first dimension, that is your number of that is your layer. So in this case, if you want to insert along axis is equal to 0, that means we are creating a new layer. Okay, now let's look at the argument for this np.insert function here. Okay, so the first argument is the array in which we want to insert something. One is the index before which we want to insert some values, and minus 999 is the values or the array of values which we want to insert with, right? And then this is the axis along which I want to insert those values. So if I run this one, okay, so it will insert, see, it will insert a 2D array, okay, of consisting of values minus 999, and this is inserted before the layer index 1, right? So they initially there were 2 layers. Now this has been added before the layer with index value 1. That means your second layer from the original array. Okay, so in this way we can insert so in this way we can insert with particular values, okay, along a particular axis and before a specified index here, okay. So if we can, yeah, just see the insert here. So see, it will see. So the thing is in values. So this is the values to insert into array. If the type of values is different from that of array, values is converted to the type of array. So values should be shaped that so that this is legal, right? Means you should have at least these many values. So in this case, if we are adding a long axis equal to 0, so we had to have this 2D array, right? So now let's move ahead and see if we can do insertion along other axes as well. So suppose if I want to insert values which are minus 999, okay, and I want to insert this along axis 1. Okay, so what is the axis 1? That means your rows. Okay, so because there are two layers and each layer has yeah, rows, right? So rows defined for each layer. So this will be added to both the layers. Okay, and where it will be added? So it will be added for both the layer with before the row index 1. So see, this is the first layer, and which was the row with index value 1, this one. So this particular row will get inserted before the row index 1, and similarly here as well, right? So you are understanding this concept, right? So if you want to insert some set of values, okay, along an axis 1, that means we are sort of trying to add rows. So because each layer will contain rows, right? So depending upon the number of layers, it will create that many rows, okay. So hope you get this idea. So when we want to insert along axis 1, so this is the index before. So suppose if I want to index add before the index 0, and let's say with value, let's say 50. So what this will generate? So see, for both the layers, it's adding yeah, it's adding a row before the 0th index, 0th row index, in fact, right? So in this way we can have that, right? So so in fact, see, that's why this idea of axis is very important. The first axis corresponds to the first dimension. So when you are, let's say, printing the shape of your array, so suppose if you have a 3D array, right, whose shape is 2 comma 3 comma 2, that means, so in this case, I'll take this particular example. So in this case you have a 3D array in which you have two layers, three rows in each of those layers, and four columns in each of those rows. Let's confirm this once. Okay, so I have two layers, right? This is fine. Then there are three rows in each of those layers, right? So there are three rows. So this is three row in one first layer. Then again there are three rows in the second layer. Now let's see if there are four columns in each of those rows. So there are four columns, right? For each of those rows, there are four columns, right? So this is how we interpret the shape of the 3D array, right? So the first dimension will correspond to axis 0, the second will correspond to axis 1, this will correspond to axis 2, right? So in this case we have a is a 3D array and we want to insert with some values. Let's say if this were 100, okay, I want to insert this before the index 1, okay. So yeah, this will create another layer, in fact, with all the values 1, and this will be before the index 1, and the axis is 0. That means this will create another layer, right? Initially we had just two layer. When I'm asking it to insert along an axis 0, that means it's saying that because there are two layers and I want to insert yeah, in the axis 0, that means the layer, so I'll have to add another layer. So to add those values, it will create another layer of these values 10, and of course the number of rows for that layer and the number of columns in that rows, those will be the same for consistency. Okay, so I hope, yeah, this is pretty clear to you. Okay, can you write yes in the chat if you have understood the concept of inserting along a particular axis? uh, yeah, so this is pretty, yeah, straightforward. So you should understand the basic concept of axis, the first dimension of a multi-dimensional array. So axis is not defined for one dimension, keep that in mind. So if you have 2D array, so the first dimension will correspond to axis 0 and the second dimension will correspond to the axis 1. But if you have 3D array, the first dimension will correspond to the axis 0, the second dimension will correspond to the axis 1, the third dimension will correspond to the axis 2, in the order from left to right, right? So hope that's clear to you. Let's add elements in along axis 2 as well. So we have seen we have been inserting elements along axis 0 and 1. Let's see if we can add along 2. So I'll not have minus 999, something else. Let's say 200. Okay. So see, so for each of the row, it's inserting 200, right? And what is the index of the column before which it will add? So the index is 1. So this was the 0th index column. This was the first index, right? So it will insert before that. So suppose if I change this to, let's say 3, so where this will insert? Before the third index. So this was the third index, so it will insert this before. If I specify 0, this will insert before the 0 first column, in fact, right? So in this way, so this specifies the index before which we want to insert, and of course this will be relative to the axis where we want to append, right? So of course that makes sense. Okay, so of course you have indices for each of your dimensions, and once you have specified the index, right, so it will be inserting the elements along those axes, right? Now, yeah. So you can add another array, but you have to make sure, see, so in this case, let's say if I am, yeah, uh, in this case, let's say if I'm adding another entire layer, so you'll have to provide a layer with those consistent rows and columns. Okay, so because that's a lot of effort to write here, so I'll just provide the values. Okay, and yeah, it will just create that layer with all the elements with that same value. Okay, so you can experiment with these things. Okay, so yeah, so now there is another way in which we can manipulate our array. So this is append method. You're already familiar with the append method from earlier, right? When we were talking about list, where we were appending elements to the end of the list. Okay, so what are the arguments for this function? So this is, the first one is array, the second is values that is to be appended to array. It must be of the same shape as of array, excluding axis of appending. So we'll see regarding that. And axis, so the axis along which append operation is to be done. If not given, both parameters are flattened. So let's see an example and see how this works. Okay, so I'm just creating a 3D array in which I have 2 layers, 3 rows in each of those layers, and 3 columns in each of those rows. So suppose, so it takes 3 arguments. So I'm just specifying 2 arguments here. So the array in which we want to append, and the value with which we want to append, right? I'm not specifying the axis here. So if I run this one, so what this will do, this will return a flattened array. That means a one dimensional array. This will flatten the 3D array, right? So it will yeah, flatten the 3D array and add or append this particular value. So I'll, yeah, you can have another value. So for example 50, yeah, so this will append 50 to the end of this flattened array. Okay, so if you're not specifying the axis, but let's say if we take another example, we want to append along some axis. Okay, so yeah, so basically the thing is, suppose I have created another array which is B, and this is of shape 2 comma 5 comma 3. That means it has 2 layers, 5 rows in each of those layers, and 3 columns in each of those rows. And let's see, and then we have another array from earlier, which is A. Now this has the shape 2 layers, 3 rows, and 3 columns. So can we append these two arrays together along axis 1? That means row wise, can we add these two together? So let's see if we can do that operation or not. Okay, so yes, we can do that. Why? So see, this is the array. So this is the A, which is in front. Now this is the another array which we want to append to A, and we want to append this to along axis 1. That means row wise. Okay, that is your second dimension in this case. So see, so in A, this is yeah, this is the first layer. Okay, and now I'm appending B. Okay, so see, this will be appended below this one. So you can see here, so 355, then you will have 335 543 here, 543, then it, yeah, so all these value will be appended below this one. And then for the next layer as well, all these 5 values will be appended below this one. So you can confirm. So 243 545, then 523, this comes from array A, and then this one will come from the array B, which is the second layer, right? So in here we are kind of appending along axis, along rows, that is axis 1. Okay, so we'll only be able to append when we have the consistent shape of these arrays, okay, which we want to append. Okay, so suppose if I just wanted to append with some values, let's say 550. So can I do this one? What this will give me? So I have to specify something. So here, yeah, so this must be of the same shape as of array. Okay, so this will be an array. Okay, so here you'll need to provide the array which you want to append. Okay, so the shape must be same. Okay, so that then only this will be able to add. So suppose I created this let's say 2 comma 1 comma 3, this B. Okay, so in which I just had 2 layer. Okay, and each layer had 1 row, and each row in those layers had 3 columns. So let's go ahead and append this one. Okay, so what this will give me? So see, so now this should be clear to you. So this first 3 rows come from A, and the last one comes from B. B's first layer, right? And then the second layer here, so this comes from A's second layer, and this comes from the second layer of B. Okay, so in this way we can append 2 arrays. Okay, so the shape has to be same. Okay, the shape as in see, the shape of A was 2 comma 3 comma 3, and the shape was for the B was 2 comma 1 comma 3. So if we are appending along axis 1, so these values, that means this 1 and 3 can differ, but your number of layer and your number of columns, they should be the same. Okay, so the dimensions apart from the axis where we are appending, so those have to be same, right, in both the arrays which we are appending. So keep that in mind. Okay, so you experiment with this, this will become pretty clear to you. All right, so now moving ahead, so we can also manipulate our array in which we have a function numpy.delete. So what it does, it returns a copy of array with the elements specified by object removed. Note that delete does not occur in place. If access is none, out is a flattened array. So what are the arguments it's taking? The input array in which we want to delete something, the object, so this can be a slice, an integer or array of integers indicating the sub array to be deleted from the input array, and the axis from which we want to delete. Okay, so let's create this one, this array, and this is a 3D array, 2 layers, again 3 rows in each of those layers and 3 columns in each of those rows. Now I want to delete along axis 0. Okay, and here I'm specifying the index. Okay, so the one, so ideally this should yeah, remove the layer with index value 1. So what this will do, what do you think? So see, this returned me an array object in which it removed the layer with index value 1. Okay, so suppose if this is 0, so what this will remove, yeah, what this will return, so it is returning the layer with index value 1 because it has removed this one. So when you are just calling the np.delete function, so just keep this in mind, this returns a copy of array with the elements specified by this object remove. So it will remove the object and then whatever that is left, it will return that thing. Okay, so we can also delete along different axes as well. So suppose this is our array, right? And I want to delete along axis 1, that is row wise, and I want to delete the rows with indexes 0 and 2. Okay, so because here I have 2 layers, so in each of these layers I have 3 rows. So in each of these layers, the row indices with values 0 and 2, they will be removed. So if I run this one, okay, so you can see that only the row index with value 1 here and 544, so this is getting returned, else has been deleted. But of course this does not change our array, so you can go ahead and print this one. So this does not change your array, but when you apply the np.delete, so you what are the arguments, let's go through again. So this is the array in which we want to delete, this is the indices okay, of which you want to delete. Okay, and you specify the axis along with along which you want to delete, right? So here I want to delete along axis 1, that means row wise. So these 2 row indices, the rows with these indices, they will be deleted. Okay, so suppose I want to I now want to delete along axis 2, that means uh, basically if I remove this one, so can you tell me what this will print? Okay, so here what I'm saying, I want to delete elements along axis 2 and I want to remove columns with indices 0 and 1. So this is our array. Okay, so what this will return, uh, can you guess? Yeah, so Satya, so yeah, so this will yeah, remove the first and second column, right? So I'll just go ahead and print this one. So see, it will just, yeah, remove the first 2 columns, right? Because they correspond to the indices 0 and 1. So it will just remove the first 2 columns from each row in each of those layers. Okay, so you should are you keeping in mind this particular terminology which I have been repeating over and over again? So if we are talking about a 3D array, so if I have 2 layers in this 3D array, then I have 3 rows in each of those layers, and then I have 3 columns in each of those rows. So this yeah, so this terminology brings a lot of consistency. Okay, so keep this in mind. Okay, and yeah, so yeah, so there is another way in which we can sort of get some information about our array. So this is np.unique. So this takes an array as an input. There is another return index. So if this is a boolean, if this is true, it will return the indices of elements in the input array, and return counts. If this boolean is true, it will return the number of times the element in unique array appears in the original array. So let's go and see the example. There is also return inverse, but I have omitted this for now. We'll discuss about this later when we actually learn about linear algebra. So I'm just skipping this for now. Okay. So this is my array. Okay. And if I am not specifying any extra argument, I'm just specifying the array. Okay. So what this will return? So this will return the flattened array. Okay, and this will return only the unique elements from this array. Even if it's a, let's say, 3D array or a 2D array, it will return the flattened array. Okay, with all the unique elements. Okay, so you can see that what are the unique elements? 2, 3, 4, 6, 7, 8, 9, 15, 18 and 19. Okay. Now let's say if I also want to return the counts of those, so it will return the corresponding counts as well. So see, 2 is occurring thrice. Okay, so you can verify 2 is occurring thrice here. Then uh, let's say you have 7, right? So 7 is occurring 5 times. So let's verify. So 1 time here, 2 times, 3 times, 4 times and 5 times. Okay, so this is returning not only the unique elements but their corresponding counts as well. Okay, and suppose if I give this return index is equal to true, so this will also return the index. So but because the elements are yeah, so yeah, I'll just print this one. Okay, okay, so in this case what it's returning, so for the element 2 it's returning the index of the first occurrence. So 1 here, for 7 it's returning 2 which is its first occurrence, and for 8 this is probably 15, right? So 15, 16, 17, and of course yeah, the total number of index is 17, that means 18 elements, and you can verify that the size of this particular 3D array is 18. So hopefully this is clear to you. Okay, yeah, so it's yeah unique, it's just like set. Okay, and using a different boolean, so we can have this boolean here as well. Okay, so it will also return the counts. Okay, so yeah, so it returns 3 arrays. So the first is of course the unique elements, the second is your the count, right, the indices of those, and the third is the counts of those elements. Okay, so yeah, it's pretty straightforward. So unique function yeah just generates a flattened 1D array. In fact that's an oxymoron in fact. So if I'm talking about a flattened array, that has to be one dimensional. Okay, so it will return a flattened array. So even if we had a 2D array or 3D array, I have been yeah taking example of 3D array, but if you just had 2D array, this will work the same. Okay, so no difference in that from that.